So we're taking functions. We've been evaluating functions last week. We took a quiz on it. I threw 10 functions at you on Friday. Just evaluate them. Now we're going to shift to a little higher gear. But before we shift into higher gear, let's just review what's going on. Go ahead and write example 1. Evaluate the function when x equals -8. So this is another example, just like warm-up. Ms. Martinez came up, Mr. Perez came up and did this for us. Now that here's one more, just to review. On your notes, underneath -8, go and write input. Right? Whatever x is, that's your input. That's your independent variable. Underneath f of x, go ahead and write output. All right? Last week I gave you this little picture of this funny little function machine here. Looks like this. Remember this function machine? The inputs are your x values, and the outputs are your f of x values. Input, machine does some with it and spits some out. Okay, that's what you're thinking of right now. So f of x is always your output. And let's go ahead and do this one here. Just lost my place here. Here we go, here we go. Okay. So what is this function at -8? Write this with me. -8 times -8 squared. Wherever I see x, I'm going to place a -8. We're used to this. So the function at -8 is -8 times +64, correct? We do the exponent first. We just talked about this on warm-up. And then -2 times -8 is +16, right? You with me, I trust? Let's keep going. So the function at -8 now, so 64 times 8 is -5. Yeah, so it's 512, but negative because the signs are different. Very good. So -512 plus 16. We're rocking and rolling. So the function then at -8, 512 minus 16, signs are different, could be a -496. That's kind of strange. So there's my output. Go and write output here. The machine spit out -496. I put in -8, it spit out -496. So underneath this, if you're going to put if graphing, the coordinates would be, the input was, what was the input again? -8. And the output would be the function at -8. Look at it. That would be, if I was graphing, it would be -8 f at -8. But we just figured out what f at -8 was, so this is really -8, -496. See, this and this mean the same thing. That's the transition I'm trying to get you to see at this point in Math 3. Input, output really means -8, -496. These mean the same thing. The function at -8 is -496. That's if we're graphing those points, applying them on the x and y axis. Now, let me throw you a curveball. I gave you the input, ask you for the output. What if I gave you the output and I asked you for the input? Take that machine and I got the output. What would be the input that corresponds to the output? So this is going to be example 2 in Dodger Blue. Here we go. Go to write on example 2. Find the input for the given output. And let me give you the equation. So Dodger Blue, since they're going to be winning the World Series next year. Uh-oh, uh-oh. F of x equals 6x plus 9, semicolon. I'm going to give you the output now. The output is f of x equals 21. I'm going to write that down. Okay, so on your notes, notice I gave you the output. It's right there. Put an arrow and write output. How in the heck are we going to find the input now? I'm throwing you a curveball. Munguia used to be an awesome pitcher. I'm not sure if you're aware of this, but I'm not just some nerdy math teacher. I am that, but I used to actually be a good pitcher. I used to strike people out like crazy. And so I'm throwing a curveball now. I want to see who I'm going to strike out. My curveball is I'm giving you the output. How would I figure out what the input would be? So I've been training you. I give you the input. Look at x equals -8. We got the output. Cool. You know how to do that now. How do you suppose we can do the number 2? Extra stamp. Uh-oh. Plug in 21 for what? Oh, for x here? But that would be the input. Remember, x is always your input. For f of x? Uh-oh. Look at f of x. Doesn't that mean the output? Okay, careful though, watch. We can only solve it if we have an equation. Look at, so what do I replace this, Martinez, f of x with? 21. Look at, f of x is 21. If that's 21, then wherever I see f of x, I will replace it with the output. Watch this now. 21 equals 6x plus 9. Are you kidding me? This looks like a Math 1 junior high equation. This is why you took Math 1. Get x by itself. Those of you in math support with me, we did equations. Getting x alone. How do we get x alone? Let's get x by itself. So let's get rid of the 9, then get rid of the 6. Let's do this. Nice. Look at this. So I couldn't strike out Martinez or Perez. Good job, you guys. By to the 9, right? I got 6x equaling 12, if I'm not mistaken. Thank you. Remember Math 1 time? All that Math 1 stuff? That's why you took that first. By to 6, so I got 1x on the right. 2, here's your input. There's your input. It's nothing crazy, yeah. It's going in reverse. Replacing the output with what the output is. Nothing crazy. Let's try one more example. Yes, it's another. Okay, good. Right, so in you're actually, what you're saying is just do it in your mind. Just think of a number, if you multiply by 6 by, and add 9 to it, it should be 21, totally. So what we're doing algebraically, this is all algebra, you're doing all in your mind. So yeah, absolutely, you could do that in your head, if you're able to. But sometimes the equations get kind of crazy, and it's going to be very difficult to do in your head, but yeah, absolutely, good. Now in Math 1, when they taught you how to, because you didn't have Math 1 with me, when they went over equations like this, how to get x by itself, they taught you how to get x by itself because you're going to be dealing with equations that you can't do in your head. Like you'll be for days thinking of x values that'll make it true. So they taught you the method to get x by itself. That's what the whole point was. But yeah, any equation I throw at you, you can start playing around with numbers until the cows come home, until you finally get one right. It'll just take a lot of time. But this one is kind of easy because it's 6 times x. But yeah, here we go. Example 3. Any questions on example 2 here? Okay, so it's working in reverse. I give you the output, give me the input. Big deal, right? Let's do example 3. Nothing crazy. Find the output, or find the input rather again. Let's do it again. Find the input. Here we go. This time this function's name is g function. G of x is negative 1/2 x. Oh no, there's a fraction. It's time to run to mama. It's time to run to mama. Rodriguez, I'm done. Just because of that. And now look at this. I'm going to give you the output. The output is all right. So the mission is to find the input. I'm giving you the output. Here it is. Here's your output. All right. Let's replace the output with what the output is. The output is negative 1. Let's do this. Negative 1 equals negative 1/2 x plus 3. You guys are Math 3 students, so we don't have to run to mama anymore when you see a fraction. You guys have YouTube, like that guy from that video told you. If there's something you just YouTube, how do you deal with a fraction? How do you add fractions? You get thousands of videos. How do you multiply fractions? Thousands of videos. Divide fractions? Thousands of videos. So you guys got the tools now that I didn't have. So, nice. What? Let's do it. Whatever you do to one side, do the other. Beautiful. Let's do it. Bye-bye to that. Bring down the equal sign. Negative 1/2 x. Negative 1 minus 3. Help. Awesome. Beautiful. Let's keep going. Now, run to mama time. How to get rid of that negative 1/2? Don't make me cry. Someone help me. You could. But then we'll have a decimal. Then how do you get rid of the decimal? Real quick. Yeah. Let me hold that thought. I'm going to deal with this real quick. So, how do you change that to decimal? Just out of curiosity. I'm just going to entertain Estrada's idea, because it's not wrong. Technically, it's not the route I would do it, because you don't have to change the decimal. But let's say I do change the decimal. How do you change the decimal? I'm sorry? Okay. No need for decimals at this point. We can just deal with fractions. How do we get rid of the negative 1/2 though? Multiply it. Okay. So we want to multiply both sides by negative 1/2. Is that what you're saying? Multiply both sides by negative 1/2? Because remember, in equation, I got to, whatever I do to one side, I got to do the other, because it's an equation. Okay, I promise Rodriguez he's going to go first, and I'm coming to you right now. Rodriguez. Under where? 4? Right, because you could put a 1 underneath any number, and it's legitimate. So, okay, now what? What's going on over there? Martinez, save the day. My question is, though, look, we got a fraction. We got an equation. What are we going to do to both sides? We have to do something to both sides because it's a balance. So whatever you do to one side, I got to do the other. So what am I going to do to both sides to get rid of the negative 1/2? So what am I going to do to both sides? Hold up, Perez and you guys. Someone talk. Ayala, give it to me. Divide by what? Okay, thank you. Rodriguez. Ayala, you're right. We are going to divide by something on both sides, because look at negative 1/2 x means negative 1/2 times x. The opposite of times is division. So I'm going to divide both sides by? Good try. Divide by negative 1/2. Let's look at this. Watch this. Anything divided by itself is it's just 1, so I got 1x. Anything divided by itself is 1. X is by itself. Now look what I got. Negative 4 over 1 divided by negative 1/2. Junior high school, if you're dividing by fractions, rewrite it from left to right. That means horizontally. Watch this. I'm going to rewrite negative 4 over 1 divided by negative 1/2. Yeah? Now, when I divide by fractions in my junior high school years, the teacher taught me to change the division to what? Multiplication. Look at multiplication, but by the reciprocal. Flip that puppy. Negative 2 over 1. Right? What did we learn in junior high? How to multiply by fractions? Numerator times numerator, denominator times denominator. So we're rocking and rolling. So x then is help. Positive or negative 8? Thank you. Done. Here's your input. All right.